computer science class thingy, sort of, whatever. Yeah. So today we've got, we're kind of starting to step away from recursion, and actually next lecture we are going to like completely move away from recursion. So.
Oh, we're back to recursion?
No, we were.
We're moving away.
So. Yeah, I think I'm gonna try to wrap this course up by the end of August. Just kind of have some definite structure and end to it. We should be able to kind of. If there's anything you guys want to learn between now and then, let me know. But yeah, so I want to kind of start going. We're going to talk a little bit higher level. We're going to go back to Turtle, which we were talking about a couple of weeks ago. And then, yeah, just kind of talking about program structures and a little bit more about variable scope and kind of why we have it. And yeah, so bring up some slides. Whee. So yeah, I want to talk today about program structure and various forms of pond life. So we were talking about Turtle the other day, and we're going to keep talking about it. So, as we saw the last time we pulled this up, Python, most installations, you won't be able to do this on Cloud9. You'll have to, if you have a Mac, it comes installed. You'll have the app Python installed locally, though, which is nice. So you just open up a terminal window. I'm going to clear this out just so I can get. I'll just close this and restart it. If you're on Windows, you'll have to go and download Python. It'll install some on your hard drive, and you'll have to open up your command line to. But so today we're gonna kind of walk through a little bit more with Turtle and kind of fun things we can do with that.
So you can't use Turtle unless you're in your own version of Python.
Yeah, you have to be doing this on your own computer. You can't do this on the online Cloud9 because Cloud9 gets all confused because it doesn't know what the display is, so it can't draw anything to a display.
Oh, this is the thing that draws. Okay.
Yeah, but so we're going to open up Python. I'm typing in Python.
There's a definition. The thing that draws.
Yeah. So the first thing we want to do is import Turtle. Let's do it. It's a library that lets us go ahead and so now we can start doing Turtle commands. The first one I'm going to do is super important. We're going to change the shapes. It defaults to a little triangle, but we want to make it into an actual turtle. So we can go turtle.shape, turtle. Oh, that's going to draw something. Hey.
What?
We got a turtle. Holy shit.
Oh my god, I got a turtle too!
What up? We're going to make our turtle do stuff. So, hey, turtle. Let's go forward. 100 pixels. Oh, holy shit, it moved. Whee! You drew a little line behind him. You know, and everything. Rotate him.
Now, does it have a whole library of names like turtle? I mean, you can put in frog.
It does not have a frog. It's a pretty small library.
Oh.
That's awesome.
But yeah, you can make it. It's got a couple. It's got a couple of options.
Okay.
So you know, we can turn the turtle right.
And what if I wanted to get a list of the options it has? I'd go on Google and Google.
Yep. Google Python
turtle list.
You go forward again. 100. Oh shit.
I'm making a weird zigzaggy thing.
Now, can you define right and then a certain number of degrees instead of
So you go.
You didn't define 90. You had to go forward 90 pixels.
So we went forward 100 pixels, then we turned right 90 degrees, then we went forward another 100.
Okay, that is degrees. Okay.
Yeah, so you go 45, and then turtle dot forward 150, turtle dot right 90. You can do this all day long.
And you could go left,
Yeah,
or do you go right and then you go
turtled
minus
off my,
90?
maybe you
that's
could do
a lot of
both.
turtling right there.
Okay.
A little turtled out. Oops. Can I do turtle?
So we get all sorts of options here. Marches around and draws stuff.
Size. Ooh, you can make the line bigger.
But
Is there backward?
there is backward. You can go backwards. We'll get to some of the other commands. But I want to kind of talk about structures. Turtle's great. This basic thing from Logo is kind of the originator of it back kind of in like the 60s. This is kind of this like programming language for learning things and how like computers work. They can go step by step and do commands. But rather than have to type out all these things every time, we might want to go a little bit higher level. We might want to do something like draw a square. So we could actually just write a function for that, right? Makes sense?
Mm-hmm.
So we can go ahead and so we can hit reset.
Yeah, how do you
Oh, turtle.reset. And that'll send our turtle back to start. So we can go ahead and go def draw square. And I want to give it a size variable so we can draw squares of different sizes.
Oh, okay.
So we're going to define. Okay.
Go tab. Let's go forward by size. Go right 90 degrees. Forward size. Right 90 degrees. Forward size. Right
So it's something a little bit wrong.
degrees. Forward size. And we'll turn back so we're facing the same direction as we started. And now we can just go, hey, draw a square. Oh, screw this all up. Because I didn't, so I forgot to write in turtle after every line. So I'm gonna draw a square again. Turtle dot forward size. Turtle dot 90. I can actually go up twice to repeat the command, which is handy.
What? Up twice?
Yeah, so if you go up and down, if you're in the like interactive shell,
Okay, you
do
mean
the
this
last
arrow
line.
up?
Yeah, up arrow or down arrow.
It'll just do it again.
So yeah, it'll
Okay.
give you it'll like repeat the last thing you had. So now I can go draw a square, 90. Yeah, drew a square for us.
So could
We have to do turtle forward.
could
turtle,
you have done that with a function, somehow a function that did the 4 commands, like said 4x dot turtle forward, or
That'll
4
be-
times, I mean.
That'll be the next lecture.
Oh, okay.
We'll have to start doing some iterative loops. So kind of iteration's really good for doing the same thing over and over.
Okay. So you could use that for, like, you could do the same thing and then draw octahedrons or something.
Yeah. I mean, we could also make this recursive if we wanted to. If we hit it live. So now you can hit up and down on the keyboard. I'm going to give you the last commands.
What? Shortcuts.
Yeah, it's just a
Oh,
shortcut. It basically says.
And it looks like it kind of messes up when I do tabs, so I just have to like manually do the spaces.
Sure.
Okay, yeah, that's what I figured.
And you don't have to use the Alt key or anything on the up and down. You just do the up.
Yep, just up and down. And
What
that
happens if you use left and right?
just moves the cursor back and forth.
Oh, okay.
How many do I have to do? 1, 2.
You have to manually do the spaces. That's not good.
Huh.
4.
So how would
Go,
I get the
turtle,
to move
go.
at this point?
So hit enter again to finish up your function. Now type in, now actually call the function. So you draw a square and then however big you want it to go.
Just any number?
Yeah, however large you want the size to be, right?
So it's like 5 pixels, so like 70.
Really small.
This.
Oh, okay.
Yeah.
I like the picture.
It's so satisfying to actually like
See it.
see the
So-
output.
Yeah.
Mhm.
Did you?
Awesome.
It just looks that way. That they're one's
Yeah.
smaller and one's bigger as a line.
Yeah, it's just the aliasing things going on.
Oh, so now you're making the design. Ooh.
Yeah.
Ooh. How do you change where it starts?
You got a couple different ways to do that. We'll kind of get into that.
Turtle
Okay, I'll just
forward
be
30
solid.
and then start there.
Yeah. So yeah, we can put those things together. So we have this draw square thing. So we could write this little function that kind of moves it around, and I'm just gonna copy paste this one. That's not what I wanted to do. Oh. So here, it's going to be set.
So after you reset, can you still use that function?
Yep. Reset just kind of clears your drawing window over here.
Gotcha.
But all the functions that we're writing, they still exist within kind of our current Python environment. So I can now go draw square pyramid, small one. And so this, you can kind of see in this function, it draws a square, then it moves the turtle. So it can draw another square in a different space, and then it kind of moves the turtle again, so it can draw the third square in the right place. So it's just kind of this example. Draws it. Draw the square, moves, draw the square, moves, draws the square.
Now,
So yeah, so just kind of the concept here is that basically we're going to take these little small blocks of code, draw squares. It's like, turtle can draw lines and it can like change to different angles. And then, so we can use that to build this like draw square function. Then we can use that in another function, draw square pyramids to draw a little stack of boxes. So basically, all your programs are going to be kind of these collections of small functions that, you'll have a bigger function that'll call different smaller functions, kind of put them together. Does that make sense?
Yeah. So it's like a bundle.
Yeah.
Or I don't know.
So like as you write your programs, and you have this, when we're writing software, like our goal is to stop the screen share real quick so I can face people. Yeah, as we're writing software, kind of our intent is this high-level thing. Maybe we want to go through our, entire database full of names and, change it to make sure that every name on our database is capitalized. So what we're going to want to do is we're going to take that big high-level goal and we're going to want to break that down into smaller chunks. Say our first thing might be like load in the database into like a list of the names that we want to use. The second thing might be to have a function that looks at a name and and capitalizes each name. And that capitalize function might go through each letter and be like, oh, call another function that says like, is this letter capitalized or not? And so basically we wind up making all these, we take this big problem, break it down into like smaller tasks, and take those smaller tasks, sometimes break those down to even smaller tasks, and rewrite functions for all of those. So I think probably I haven't put together kind of the homework for this week yet, but basically I think the homework for this week is going to be a lot of drawing stuff with Turtle. And it's going to be a lot of, okay, like the strategy for that assignment should probably be, go ahead and write all these little small helper functions that will do things like draw a square, draw a triangle. So you'll be able to then, take, a square and a bunch of, triangles or circles or something, draw a tree, and then you'll have this function draw a tree that draws squares, which draw lines, and then you might have a draw a forest function, which draws a bunch of trees. So just kind of that stacking functions all on top of each other. That's kind of the goal with a lot of this. But I should share screen again. Yeah. So other common Turtle functions. If you want to look at the entire list, and some of them kind of get into the weeds, but you can Google Python Turtle. Kind of some of the key ones, the easiest to use are, so use forward, backwards kind of does the same thing. It just moves Turtle backwards, obviously. We have left and right. We have circle, which will draw a little circle. So you can try that out. So set circle. And I'll draw a circle with a radius of whatever you put in. So.
Turtle circle?
Yep, turtle.circle.
Now there was a function of go to xy.
Mm-hmm.
How does it count? I mean, I assume that's vertical and horizontal.
Yeah.
How does it count, or where does it consider 0.0?
I'm gonna guess it considers 0.0 the center of the screen. Let's find out. Let's turtle.go to 0, 0. Let's see where he goes. He didn't go anywhere, so 100. Oh, that's 100,000. He went way the heck off the screen. Let's send him back to 100. Hey, he's back there. So go to.
So the screen's about 600 by 600, the way you have it right now.
Yeah, I'm not totally sure, but yeah. So it looks like we can probably go, 600 this way, -600, -600 or something. So go to is this nice little, lets us, go anywhere we would like to. So super convenient for repositioning in kind of this absolute way. Yeah, I guess if
And the pen up thing means it won't make a mark when you do that.
Yeah, so if I wanted to set up, we go turtle.pen up, and turtle.go to -100, 100.
And you have to do pen down to get it to. It doesn't reset unless you reset it, so to speak.
Yeah.
Or read.
So I go pen down, turtle.circle, draw a circle over here, up again. What do we get?
So you have to do turtle pen up, and then you have to tell it to go to.
If you want it to move without drawing.
So turtle pen up first.
That kind of brings up a point that'll be useful to all of you guys who want to do graphical programming, things like processing or Unity or things. Excuse me. We'll have to hang out again. Actually, it's back in. It's easier for me to find. So, if I use the words like absolute position versus relative position. Do those terms mean anything to you guys?
Wait, what was the term?
Absolute position versus relative position.
Well, in terms of Platonic philosophy, yes. But that may not help here.
So tell us what Platonic philosophy has to say about absolute and relative position.
Well, there's, in Platonic thought, there's the absolute, which is a singularity and is the one and only thing. And then there's these ideals, like we can have an ideal of a chair, sort of thing.
Sure.
And those are relative, but they're closer, if you want, to the absoluteness than actually any actual given physical chair, because that physical chair is then a concatenation from that ideal, which is then from the absoluteness. How are we doing?
I don't know that it helps a ton, but but it was informative. We appreciate that.
I guess the absolute is something can be variable or move around.
Yeah. So Jenny kind of hit it. So absolute positioning is the idea that we have. So let's say we have a grid of pixels, like a screen. An absolute coordinate system would be, so maybe 0, 0 is this bottom corner, and 640, 480 is this top corner on this 640 by 480 window. So absolute positioning would be, okay, I'm going to draw a circle at 100, 100. I'm going to draw a circle at x equals 500, y equals 200.
Oh, I know where these terms remind me of making windows for websites.
Yeah. So if you've done any web development,
That's all coming back.
or or any of the stuff like absolute positioning says, okay, we're gonna basically be working in this two-dimensional or even three-dimensional space, and each pixel on this screen has a coordinate, and we're gonna draw something at that exact coordinate. So that's gonna show up on your screen, in that exact space. Whereas so that's the go-to command. The go-to says, hey, I'm this turtle. I live on this grid of pixels, and I'm going to go to this exact pixel that you told me to. I'm going to go to 100, 100. And with our turtle, it starts in the center. So I'll swing back to the screen share. So with our turtle, our turtle dot go to 0, 0, so x 0, y 0 moves it right back to the center here. So our positive 100, 100 was up to the right. Negatives were down to the left. So that's telling them, based on this as our 0 point,
As an absolute place.
We go here. A relative positioning says, okay, the turtle is currently somewhere, and I'm going to move relative to that. And with the turtle, it's always, the only way the turtle can move is forward and backwards in relative motion. But, that makes sense. So if we want to go turtle dot forward 100, or actually, so let me pull back real quick. So if I say go to negative 100, negative 100, that pixel is always right here. So turtle never moves because that's the absolute position that it's at.
Mm-hmm.
It's like saying, go on the freeway, go to exit 30. If you're already at exit 30,
you're done.
Yeah, you're there. Otherwise, if you're at mile marker 5, you have 25 more miles to go.
Mm-hmm.
Relative positioning is saying, okay, go 20. So you're at mile marker 5. Go 25 more miles. That gets you to marker 30, but then you could be like, okay, go 25 miles more, and that would get you to mile marker 55. So that's like saying turtle back forward 100. So that moves us forward 100. I head forward again, and each time it's moving
the turtle forward 100 spaces in relation to where the turtle was and the direction that the turtle was pointing.
Now, if you wanted to create the motion that had been created by it moving from 0.0 to negative 100 and negative 100 using relative orders, you could say move left 45 degrees.
Yeah. So 91st go and then. Yeah, so so in order to go to negative 100, negative 100,
And then say go forward 100.
I forget 144-ish, I think. Pythagoras theorem.
Oh, right.
Yeah. So it'd be 144 here is like a squared plus b squared equals c squared. So the square root of 200 is roughly 144, I think. So just random math nerd facts.
Now, where is the actual center of the turtle?
So the center of the turtle is, just kind of center-ish of the turtle.
Oh, it is. Okay.
Yeah.
Come on with butt.
Well, that's what the line seems to be doing. It's the turtle spider thing.
You're overheating? Impossible.
No. Yeah, so it looks like the turtle is centered right in the smack dab center of the turtle.
Right. Okay.
Not turtle butt.
Now, if you said go forward to the turtle from where it is, it would go on the angle.
Yep. So
Because it's turned that way.
yeah, so that's another thing. The relative position doesn't account for the angle of the turtle, so it's still pointing this way. So if I go forward by 144, it still chunks out this way because it hasn't rotated. So
there isn't moved sideways.
there is not a move sideways. So yeah, so the next thing the turtle does a really good job of talking about is the idea of states. So we kind of ran into this when we were talking with Picobot. We had what was Picobot knew what was surrounding it, and it also had this internal variable called its state. So if it was in state 0, if it hit a wall in the north, it did one thing. If it was in state 1, if it hit a wall in the north, it did something else, possibly. Turtle similarly has this concept of states that, the most relevant example is the pens. So we have, in addition to pen up and pen down, we also have pen color and pen size. Turtle draw different colors. So if you want to make it green 0, 1, 0, so it uses this instead of so it's red, green, blue channel. It uses by default values from 0 to 1 floating point values. So and you'll see the outline of the turtle turns green possibly. Well, we can do pen size. Make it real big. Go forward. Hey, we don't have a backline. The thing to notice here is that the turtle stays green, and that line stays that big. So we've kind of set the color and width state of this turtle. So our turtle has this internal variable in it that it stores called pen size, called pen color. And so when we say, hey, go forward 100 and draw this line behind you, it's like, okay, how do I draw that line? Well, I know I draw it green, and I know I draw it with a width 10 because I set its state. I set the state of its size, and I set the state of its color. And that even in the functions that we write, that state persists. So I still have draw square. I'm gonna reset. Actually, I don't want to reset because I'll probably clear things out. Go to center again, or I'll turn right. space, and then let's go square. Your little square, and it's still green. Because, like, you're
you set it up there, and it's going to stay that way until you tell it not to be.
Exactly.
Yeah.
You set it up, and it's going to stay that way until we tell it not to be, in case you can't hear Jenny, because the microphone's pointed at me. So the turtle has, so we've got pen color with pen size, direction, and the turtle's position are also part of like the turtle's state. So when we say draw forward, if it's forward 100, if the turtle's at 100, 100, it'll be now at 200, 100 if it's pointed in that direction. It's kind of again the relative position thing. So yeah. So this is kind of, this idea of state ends up being really helpful, especially when we write programs that kind of have these more persistent things that are like operating on it. For instance, if you're writing anything in processing, the way processing code works is, back to maybe, with processing, we generally, processing and Arduino both have this kind of pattern where, so processing, for if you guys don't know, is like a visual programming, or a programming language for like drawing graphics. So if you want to make like a scene that like moves and has shapes going around, like processing is a good venue to do that with, or a good program to use that to do that with.
It's a program language.
Yeah, so processing uses Java, and it's kind of an environment to write Java in. And it has a bunch of like functions that make it really easy to draw shapes and put in images and draw movies. So if you want to do anything programmatic with a movie, like Jane and I just did a piece where it kind of had but one long movie, and it kind of like looped individual segments of it until you hit a button, and that kind of jumps to the next segment. And processing is a really easy programming environment to do that in. But it kind of gives us this idea of, that's actually a really good example of like state. So we have this program that it's running this video clip, and we want it to loop a segment of this video. So it's on kind of like clip 1, and then when we hit a button, we want to switch the state. So it's still looping, but it's actually looping on clip the second part of that video. Then we hit a button, and it's now looping on the third part of that video. So internally in the program, we're storing as a state, what part of the video we want to be looping. So kind of the program is still doing kind of the same pattern. It's just doing it on a different part of the data. It's kind of in a different state. We're saying, okay, state 1 is loop on the first part of this video. State 2 is loop on the second part of this video. I'll bring back to this example that is in the slides here. Is kind of, and this is actually something that I'm doing more and more. What you can do is you can write in a debug state. So you can have your programs and you write your functions. But let's say I want to, so like most of the time when I want to, like when I'm finished with my program, I don't want it printing out a bunch of information as it goes through. But let's say it's doing something I don't know, like it's screwing up, I don't know why. So I want to write a bunch of like print statements that like kind of give me a peek into what's going on. So I might write this construct. I might create this like debug state variable. And so I can set this to true or false. And if it's true in my function, I'll go ahead and print out this, hey, I'm drawing a square size of this. And that way when I go ahead and copy paste this. Oh, crap. It's all jacked up. Back up here, right in, like this. Oh, that's why you didn't like this. I liked it better. It's curious to me. Let's go. Oh, capital T. Let me rewrite this so it's not in error. Python's picky. So since debug is true, when we run this function, let's make it a big triangle. No, what the heck? Oh, dang it. Sorry, I did not run this code before I wrote it out.
I mean, really.
Unacceptable. Just have to go some more room. I think I need to just go comments. Maybe that'll work. That is. Hey, and see, it went ahead and drew my triangle, and it also told me drawing a square because I'm an idiot, and I'm not very good at shapes, apparently. So let me go ahead and change this back here. But I can now go ahead and set the debug variable to false. Oh. Let me go back to draw a triangle. Notice it'll still draw the triangle, it just won't print out the drawing statement. So that way I could write a bunch of code that, if I have the debug equal to true, it prints out all this information that lets me know what's going on the inside the program. But then when I don't need that information, I could turn the debug state to false, and you would print all that stuff out.
So debug is a little already established program in Turtle that you're essentially calling out.
Not quite. So we're actually just going to get into that. So debug here is an example, and state variables are probably the best reason to use what are known as global variables. So we've talked a lot about variables so far, and mostly we've kind of kept the discussion to local variables. So we're going to kind of go and recap through some of this stuff. So just real quick, variables. Okay, screen sharing good. Variables are these little boxes for data. We want to store some data in our program so we can use it within our program. We give it a name and slap some data into it. So we have name variable. Put Alice into there, and now if we type in name variable, we get Alice from there. Equals puts data in there, and we'll just totally overwrite any data that we had there. So name variable had Alice in here, and then we stuck Bob in there, and so now name variable is equal to Bob. These are kind of simplistic examples, but things get more useful when we actually can use them to store results of computation, like seconds per hour. Well, I know there's 60 seconds in a minute and 60 minutes in an hour, so seconds per hour, I can type this out, and this makes more sense than just jumping into 3600. Furthermore, you can define them kind of in a cascading thing. So I know seconds per hour, I can multiply by 2040 the number of seconds in a day, which makes a lot more sense as when I write out seconds per day than if I wrote out 86,400. And finally, we get data into a variable from a function. So we've kind of gone over this a couple times. But this return statement is super important because that's how we have a function give us back data that we can stick in a variable so we can use it later. So I have this function add year, which takes in an age. It prints out happy birthday to the console just to tell me, oh, happy birthday. But then it returns age plus 1. So it's actually going to change. It's actually going to give us back a new age. So if I say my age is equal to 31, That's stored 31 into this variable called my age. So if I type in my age, it'll say, hey, and you've got 31 in there. Now if I go ahead and say my age, that's actually equal to add a year to my age. It'll print out happy birthday, but then it'll take 31, add 1 to it, and return that back into, from here, this will take that and stick it back into my age. So now if we ask, hey, what's in my age, it's 32 now. So this kind of brings us to global variables. So we've talked a little bit about variable scope before, where variables that exist inside a function, you can't access them from outside of the function. So if I have this, add year with this local variable age, I can't just type in age. If I type in age, it'll be like, I don't, if I'm down here, if I type in age, it's going to give me an error because it doesn't know what age is. Even though it exists within here, outside of this function, we don't get to see it. What's known as a local variable. So even though it's like the last example, okay, we went ahead and hit add year to my age. So right now it's, let's change this to a print statement.
If you do print, it would, and you did my age down below, it would know what it is, but you wouldn't have saved it anywhere.
Yeah. So if we go so let's go ahead and say my age is 31. So add year to my age prints out happy birthday. And now it's also going to print out 32 because it prints out. So it takes in the age, adds 1 to age, and then prints it out. So it's happy birthday and prints 32. Let's go ahead and call it again. Add year my age. It still goes ahead and my age didn't change. It's still 31, so it still sticks that in. So it still prints out happy birthday 32. Because age, even though it's kind of changing in here, all that disappears once add year is done.
But if you return it, it doesn't disappear.
If we returned it, my age we'd have the data stored within whatever we stored it into.
And in this sequence, you'd have to print it out first and then return it.
If we wanted to see it on the
If you
console
wanted
like
to have
this.
it saved.
We'd still save it without the print. We just wouldn't see it show up.
Oh, yeah, right.
Yeah.
But if we tried to put the print statement after the return, it wouldn't know what age was.
Yeah.
After the return.
Yeah, the return would just stop the computation and you'd be done. So meanwhile, we could do something, we could create a global variable. So this is creating a variable outside of a function, so it's in the global scope. It just exists, right after the carets or, at the very far left of the file that you're working in. So whereas add year is the only thing that gets to know about this age variable, everything in your program gets to know about this global age variable. We declared it in the global scope, so you could write this function add global year, which doesn't even have to take in any input, and it just adds 1 to global age. There you go. Go ahead and print out global age here to make it match up. So now,
But to get a global variable, you have to put global in front of it.
no, you just have to put it in outside of a function. I'm just calling it global age just to make it clearer.
Okay.
So yeah, now we add global year, happy birthday, and when we print out global age, hey, it's 32 now. If we run the function again, hey, we're taking global age, adding 1, putting it back in, and now it's 33. We can do that, and it's always gonna add because global age always exists. So if we want to do something like store a state variable, like, hey, what clip are we on in this video that we're looping on? Having a global variable for that's going to be super convenient because we can run whatever functions that we want to run, and we always know that, hey, okay, I'm on clip 2, so I need to be operating on the second part of this video, and I'm on clip 3, so I need to be operating on the third part of this video. Yeah. Global variables are also dangerous. They tend to be, there's a lot of times that, we have to use them, or they make the most sense to use, these state variables, but we want to be careful with them. The first reason is, what is known as namespace collisions, which is if we have a bunch of global variables, variables have to have unique names. If we have a variable called name, and name equals Chatham, I can't be like, okay, name equals Kurt, because as we talked about, it's going to get, that data is just going to get overwritten. So we have issues like, hey, if we have, so we imported turtle, we did a couple of turtle commands. Let's say, oh, I think I want to give turtle a name. Let's put Jimmy in here. Now it's going to give me a big error because, well, all of a sudden turtle stopped being the turtle that we can draw with, and it just started being this string Jimmy, because the computer doesn't have any idea what turtle actually is. All it knows is, oh, turtle is a variable. It points to some memory address. It has some data in it. When we imported turtle, it set up this variable for us called turtle that gave us a bunch of functions that we could use. But yeah, then when we went down on this line and said, hey, turtle is equal to Jimmy, it's just like, well, run this, we can go, yeah. Okay, turtle forward 100, turtle dot left, 90. Potato turtle. Turtle equals Jesse. I like that, Got a turtle named Jesse, apparently. That's great.
Now, what if you put in Jesse.left? Does that affect it?
We can try. Jesse.left. 90. Nope, string.
No.
String has no attribute left.
It's completely detached from
Right.
turtle on
You
the,
broke
yeah,
it.
you broke
So
it.
similarly, since turtle is actually just a string called Jesse, turtle dot left is going to get the exact same thing. It's like, hey, I have an attribute there, string. This
Don't make me do
object,
that.
this string object doesn't. I don't know how to make a string go left. So this is the first problem with global variables. That, we run into what's called a namespace, which is part of your code, especially when using libraries, for instance. They have all this data and they have all these internal variables that all have names, but we want to make sure that our names don't conflict with their names. So it's called when they do conflict, we get what's called a namespace collision, and you get errors like that where you're trying to use a variable that's been defined somewhere else, or your library code's trying to use a variable that you just totally clobbered, and your shit doesn't work, and you don't know why. Because you get this weird, I'm trying to access this, and it's I'm expecting a float, and you've got a string. Reason 2, things change when you don't expect them to. So this is kind of an example with, and this is something that will probably happen with something like a state variable. So we might have this color. If we were, you'd run into this. If you're drawing with your turtle pen, you would set the color to something. Then you have this function that draws a tree, and that function that draws some flowers, maybe some other functions. Then at this point, hey, what's in color? I want to figure out what's in it. Steve. Somehow one of these functions at some point said, I'm going to go ahead and set the color to Steve. I don't know why, and most importantly, I don't know where. I might have these, might call a bunch of different things. Draw tree might have a draw branch subfunction, which might have a draw leaves subfunction. It's kind of a silly example, but more likely you might have this all of a sudden be yellow, and that's useful in that it's a color, but I was kind of, when I'm reading through this, I was kind of expecting it to stay red, but now it's not, and I don't know where that changed, because at some point in one of these functions that I wrote, I changed it and I didn't change it back, and so, now I'm stuck with this. So it makes your code like more unpredictable when you're going through it. Similarly, when something goes wrong, it's hard to know where that happened. So again, somehow we got our color to be set to Steve. Is that in draw tree? Is that in draw flowers? This might be, this a 5,000 line function. I have to dig through all that and see every place where I change color or reference color and see what the heck's going on to figure out why color's Steve all of a sudden and why my program doesn't work because Steve's not a color. And finally, it's going to make your...
Wait, what was number 3? Round number.
So it's just things are hard to keep track. It's similar. It's 2 and 3 are very related. 2 is just kind of things change, and maybe I wrote draw flowers 3 months ago and I forgot that it changed color to yellow. I was just like writing a new program and all of a sudden, oh shit, color's different. I don't know when that happened, it's like I just kind of you'll have these functions that'll change things, and so it makes it hard to keep track of like the state, which you see very similar to 3. I wrote these in kind of a rush. But yeah, reason 4, it's going to make your code hard to write and hard to read. So we kind of go back to draw shape. This is kind of drawing a triangle, and maybe we defined these kind of global variables, like okay. Shape just makes it. I set somewhere in my code. I set the shape, and I like the position of the shape, and then I told it to go forward to shape size and turn this angle, and like if I'm only ever using these variables within this function, like I might as well set them up inside this function, like rather than having these global variables just kind of floating around. So if you can get away with keeping your functions like in the closest, like in the smallest scope you can, it's just going to make your code easier to understand. Because you'll wind up, if you have like a list of 500 variables at the top of your code, they're all global variables that only relate to certain parts of your code. And it's going to be kind of confusing. You won't really know like what variables you can change and what to use. You'll have to be going up back and forth versus kind of your. It probably would make more sense to be like. If x is equal to 500 shape y is equal to 400 or something. Or even better, have something where it actually takes in variables, so you could draw it in your function. You actually pass in data, so you're using local variables, but that way you can actually call draw shape. When you actually want to use it, you can kind of give it at runtime, give it meaningful data. Yeah, I just kind of want to wrap up here at the 1 hour mark. This is going to be pretty much it for today. I'd love to sit around and take questions. Naming, I've hit this a bunch of times before. It's super important. A really common way people will name things is this pattern here where, so a lot of times you'll have constants in your code that they're numbers that don't change, things like the screen width, or maybe you have a variable for like the maximum number of people who can be interacting with your thing at one time. You might have like max users. Those are values that like they exist, and they're like your code will like use them to compare things against, but they'll never change. So and a lot of times people will write them with this like all caps, underscore for spaces, and you'll see that a ton. So in other people's code, like there's a, I don't know, probably at least 50% chance that that's like some constant value that they set up somewhere. This is a little, like, this is pretty universal, this all caps underscore. This pattern for global variables, since they're kind of like dodgy to use anyways, you won't see it quite as much. This is kind of more my personal style, but I will like capitalize the first. So use what's known. So we call this camel case, where we capitalize the first word of each letter. And for my global variables, I'll go ahead and capitalize the first one. So, like when I'm writing in processing, so processing kind of works. You have like a setup function that kind of sets up things, and you'll have this loop or draw function which runs every single frame. So it's running this constant loop. Like I want to like keep count of how many frames have gone by. So I'll need, since the draw function is its own function, I need to have a variable that stays alive even after that function ends every time. So I have a global variable called frame count that starts at 0, and every time a frame goes by, it increases that frame counter by 1. But yeah, so similar like state variables, like if I wanted to keep track of the pen color, or if I wanted to keep track of how many objects were in my scene or something. So I'd do like capital F and then capital C. And then local variables, this is super common again. You'll see where people have camel case and starting with a lowercase letter. This is pretty, again, fairly universal. It's probably if you're having kind of mixed variables. I mean, most programming, I'd say probably 70 to 80 to 90% of programming, you will see, like, just because it's good program practice, like will not use global variables. It may use constants. These are super common, but it won't have like global variables that'll have values that are changing. But yeah, so kind of local variables, you'll see this kind of lowercase camel case a lot more commonly used exclusively for local variables. There are a couple of other patterns that we may talk about. Occasionally you might run into, like if you're using, something, you might see somebody has like M underscore for like a member variable, or like L for a local, or like G for a global variable or something. That's, I don't know, I've run into maybe 10% of code that I see kind of has something like that. The important thing is consistency. Is really helpful. This is like, develop your own style, but like try to stick to that, just so like 2 years from now when you're looking over code that you wrote 2 years ago, you're like, oh, I know what this is. Yeah. So Wednesday is going to be exciting. We're going to start talking about iteration, which combined with Turtle is going to let us do a lot of fun stuff in a way that makes a lot more sense than recursion does. Yeah, I think kind of recursion was kind of the hardest thing that we covered here. I'm happy to answer questions for it, but we're mostly done with recursion now that.
Okay.
Now that kind of the homework's done, it's a powerful tool. There's certain situations, especially like if you're looking through like kind of branching data structures, where recursion is super helpful. Searching through lists, it lets you kind of like divide and conquer. But 99% of the time, iteration, which we'll talk about on Wednesday, is what you're actually going to use in the real world. Solve your problems, and it makes way more sense. So we're kind of headed in that direction. Yeah, I'll stick around if you guys have any questions, or yeah, I mean, you guys have any questions about today's material at all?
Yes. No, that's clear.
Sweet. Try to keep this one easy. I'm tired, lazy.
Yeah.
Yeah.
So, hey.